Hello dear friend, welcome to Olympiadia channel. Today we have another video about how to change the quadratic equation with a recursive relationship. So here we have a quadratic equation which is an is equal to n squared minus 5n plus 6, and we plan to change and convert it to a recursive equation which every single parameter has a special coefficient. So let's read the question. The question said, create a recursive sequence from this quadratic equation. So as I said, an is equal to n squared minus 5n plus 6. This is an explicit equation, which means that for any single n, which n is an integer number, we have the explicit equation for the relation of an. So an is equal to n squared minus 5n plus 6. And we want to just convert it to a recursive sequence. So first of all, we need to check the degree of explicit equation. The degree of explicit equation is the biggest number among the powers of n. So the biggest number is the number 2. So the recursive sequence is something like this. an plus 2 is equal to an plus 1 plus an. We have only two sequence after an. If the biggest power would be 4, the recursive sequence has 4 sequence. So based on the biggest number of power, we have sequence in recursive equation. Okay, we also have some coefficient for these parameters. So we have the parameter a for an plus 1 and the coefficient b for an, and also a constant number which is added to all the equation. So the nominal equation is something like this. an plus 2 is equal to a times an plus 1 plus b times an plus c. And we wanna get this relationship. So let's obtain an plus 2 as an. If we put instead of n the number n plus 2, we can get an plus 2 is equal to n plus 2 squared minus 5 times n plus 2 plus 6. Which we can get the relationship as n plus 2 plus 4n plus 4 minus 5n minus 10 plus 6. And finally, we can get an plus 2 is equal to n2 minus n. And by replacing n plus 1 instead of n, we can get n plus 1 squared minus 5 times n plus 1 plus 6. And by simplicity, as what we did something before, we can get n plus 2 n squared plus 2n plus 1 minus 5n minus 5 plus 6. And finally, we can get an plus 1 is equal to n squared minus 3n plus 2. We can put these three relationships next to each other. So an plus 2 is equal to n squared minus n. An plus 1 is equal to n squared minus 3n plus 2. And the equation gives us is the equation as an is equal to n squared minus 5n plus 6. We can remove n squared by subtracting the first equation minus second equation. So we can get an plus 2 minus an plus 1. And by calculation of these subtraction, we can get 2n minus 2. Because minus n minus 3n plus 2 can lead us as 2n minus 2. And by replacing n minus 1 instead of n, we can get an minus 1 plus 2 minus an minus 1 plus 1 is equal to 2n minus 1 minus 2. And finally, we can get an plus 1 minus an is equal to 2n minus 4. So we can write these two equations instead of these two equations next to each other and write an plus 1 minus an is equal to 2n minus 4. Here we again remove the n parameter. So we can subtract these two equations as previous. We can get an plus 2 minus an plus 1 minus an plus 1 plus an. And in the right side of equation, 2n parameters can cancel each other and minus 2 minus minus 4 can get to positive 2. So the relationship simplified as an plus 2 minus 2an plus 1 plus an is equal to positive 2. So by moving the parameter of 2an plus 1 and an in the right side of equation, we can get the equation as an plus 2 is equal to 2an plus 1 minus an plus 2. So we can get recursive equation, and we just need to get a1 and a0 sequence of equations. So as the question give to us, we can get a1 and a0 coefficient. So the relationship said that an is equal to n squared minus 5n plus 6. So we can replace the number 1 and 0 instead of n. So a1 is equal to 1 minus 5 plus 6, which is equal to 2, and a0 is equal to 0 minus 0 plus 6, which is equal to 6. So a1 and a0 is equal to 2 and 6 respectively. So we can get the all recursive relationship as this. An plus 2 is equal to 2an plus 1 minus an plus 2, and a1 and a0 is respectively is equal to 2 and 6. We just need these two parameters because the biggest power in equationship was the number 2. So for example, if the biggest power in the relationship was the number 4, we need to get a0, a1, a2, and a3 as the first parameters. So these two numbers can be sufficient for us. Okay, I hope you all the student enjoyed this video, and until the next video, stay tuned and goodbye.